Okay, at this point, I thought I'd shift over to Excel to show you actually how like three different methods for solving this simple machine learning algorithm, if you will. It's a linear regression algorithm within Excel and what that looks like. So I'll go ahead and pull up Excel. So there we go. Okay, so this is just as we showed in the different slides that we just covered. I'll go over here. The first thing we want to do is initialize our model parameters or our theta values. So I'm going to zeros in all of those. The prediction, this is where we're going to use that matrix multiplication algorithm. Remember x comma theta. And because we haven't named them, it's just outlining the cells as we do this. So enter. And again, because it's a dynamic array, it's going to encompass all four of these values. Now we're going to do the loss function for each of these. And in order to do that, we're going to do, this will be y minus y hat. You notice that it put the hashtag because it realizes that's a dynamic array, and we're going to square that. And it's going to, each of these is going to correspond to the same row. So these first two are a loss of 1 or a high loss because the actual value of 1 is different than the prediction, which is 0. We are then going to do the cost function, and this is simply the average of the different loss functions. There we go. 0.5 is what it comes up to. Now at this point, we can do the optimization. So to find the actual optimized model parameters, or these different theta values up above in this equation. So we want to go to the data tab. Again, solver is this optimization tool. Set the objective, so we can actually go here. We can select the cost function as what we're going to optimize. We're going to force that to be a minimum. And we want to do that by changing different cells, so we can select the different theta cells. These arrows off to the side are just showing that like theta 3 acts on this column, theta 2 acts on this column, theta 1 acts on this column, just to kind of highlight which of these model parameters acts on which column. So now we can go back here. We are not going to enter any constraints. We're just going to use this nonlinear solver, so kind of the default within Excel, and go ahead and solve. So it takes a couple seconds. So I'll pull this over here so you can actually see what I see. It found a solution, and you have the option to keep the solution or restore the original values. We're going to keep the solution, okay? And you see up at the top here, that it now has optimized these such that the prediction 1100 is equal to the actual values. Okay, so that is one way to do this. And then the next thing, if you wanted to predict new values, you would do the matrix multiplication of the new x's with your theta parameters. I'm going to put F4 here just so that doesn't move. Okay, there's one prediction, and now I can Control C to copy, and I can paste it down below too. Control V to paste, and if we wanted to look at, now it's highlighting the correct cells, these new ones off to the left, and it's still using these model parameters. Okay. So that's one way to do it. That's kind of the quick and dirty way to do these problems. If I want to, I can go ahead and delete this. I can go ahead and delete these, 0. The other way that we can do this is we can actually go and assign variable names. So we can select all these. Again, go into that upper corner and just name it X. Let's name all of these theta. We can actually select all of these and use, I believe it's in formulas, create from selection. And here we can create variables, and you're just telling it the top row is going to be the variable names. Select OK. So now it's named each of these columns according to the top row. And then the last one would be the cost function. So we can, let's name it cost. Enter. OK, so the prediction, it's still going to be matrix multiplication, but now we can just enter the names. X comma theta, the mean squared is going to be equal y minus y hat squared. And the cost is going to be equal to the average of loss. And again, each time we're doing this, you can see that loss is blue, and it's outlined the correct array up above. Press enter, and there's our cost function. I should have probably left the values, but we can do solver again. When you open solver this time, notice that it's replaced the actual cell with the variable name. So it's going to set the cost function to a minimum by changing the theta variable cells. And we'll go ahead and push solve. Once again, it's solve this. Press OK. And there we go. And then the last way is to use what's called a let function, which I've outlined before, but we'll go ahead and do it again here. It's going to take, we're going to use actual multiple different lines. So this is why I've expanded that, formula bar up above. So we're going to use the let function. And in the let function, we're going to identify X, and we're going to select this. We're going to identify theta, and we're going to select our theta up above. We're going to identify Y. We're going to select Y. And you notice it's replacing the cell names with the variable name that we've already... So it may be confusing, but the second set of values, the first one's always going to be the variable, or the odd one within this function. And the second is going to be where you highlight the different cells that are going to make up that variable. Okay, so those are all really our inputs that we need. I can hit Alt-Enter and go to the second line. Now we're going to, well, we would have to calculate y hat. So y hat is going to be matrix multiplication of x comma theta. We're going to have to do the loss. The loss is y minus y hat squared. And then the cost is the average of the loss. And then I'm going to hit Alt-Enter again. The very last value is going to be the value that you output. Since we're in this cost cell, I'm going to output the cost. So press Enter. And there we've done everything within one in-cell formula. What's interesting is we don't have to have y hat and loss in order for this formula to work. And that's because it can calculate intermediate cells within this formula. So that makes it really nice if you have a lot of intermediate steps that you would like to tackle, not on the spreadsheet, but maybe within a cell or a formula. and you really only want the output. So that's where this function comes in very handy. So with that, these are kind of the three ways that you can approach this problem. Again, maybe I'll show you even the solver here. In this case, again, the cost function and theta are referencing these different cells. Even though we've deleted y hat and loss, we can still run the solver. Of course, we already had it set to the correct values, but even if they're not, this solver would work without those intermediate values. The other interesting thing is if, maybe you needed to debug and you were curious what these intermediate values were, you could go back and say, okay, I'm going to take y hat and I want to output y hat. So there we go there. Well, that's the y hat value. I'm going to go ahead and copy this formula once again. I'm going to go over to the loss function and paste it. And I want to know what the loss functions are. So you can paste those intermediate values if you want to try to debug or to see if the formulas are working, which is sometimes necessary. But the let function will do all that internally without you requiring to do those intermediate steps. The other thing I could show with this loss function is we don't need to define the cost function up here. I could go ahead and just cut that out, and I'm going to go ahead and delete. And I'm just going to output the average of loss at the end. So you can do something like that where the output value actually uses a formula as well. If I press enter, it still gives us that 0 value. So we didn't need to identify a new variable in order to make that calculation, but sometimes it's nice just to keep track of what all is going on. So with that, yes, thank you, and for hanging in there, and hopefully this helps to show you a few ways that you can tackle these sort of problems within Excel. And with that, we're going to move on to really understanding the basics of machine learning, and then from there to tackling the basics of neural networks. So with that, that's it for this video, and may the course be with you.